This talk has no technical details on NDN and lots of details on naming as a way to maybe talk about opportunities that could come up in extended reality and name data networking. So it's influenced heavily by the work done collaboratively on NDN with many of you and with Leisha and Alex and everyone. But it is not an NDN talk, and I think Leisha said that was okay. And so we are in, and it also is kind of inspired by a mentor that I had who always kind of made you describe the meeting that you just came from as context for the way that you were going to approach a meeting or presentation that you were in. So I'm in the middle of producing a very sort of large, complicated, experimental, extended reality musical, and this is about that. And as I looked at the name data in that show, it actually was a pretty interesting exercise, really, to think about the relationship between the opportunities in NDN and the types of challenges that we face in integrating this production. I'm not going to give you all of the background, but this was an extended reality and immersive theater project that came up through some conversations with Disney Live Entertainment and some other units at Disney around the new forms of audience experience. And so we were looking at integrating extended reality, which you can kind of see, it actually might be better on the Zoom, but extended reality, generative AI, and persistent virtual worlds for reasons that you could imagine in a large production company. I will spare you exactly why, but we are doing a production of the Broadway musical Xanadu, which is based on the 1980 film with Olivia Newton-John. It's Gene Kelly's last film, sort of a cult classic now, about how the Greek muses come down and inspire a failed scenic painter to open a roller disco in Venice, California. And that's about all that you need to know about the show. Lots of work by folks here. I just have on this slide some of the folks involved in the generative AI and digital design components that I'll talk about in a second. So the way that this show is conceived is it has an onstage world made of some large rolling screens, actually about 7 of them that you'll see actually fabricated here, so they're quite large, that provide access into a virtual world in Unreal Engine. And the audience interaction is essentially connected to different aspects of the relationships with these large screens as the musical unfolds. And the students are involved in both designing the physical fabrication and the virtual world. This is what's on stage right now, up in the other end of campus. So 7 large 13-foot rolling screens that display this sort of virtual world. But where the audience interaction starts is with mobile phones. And that's kind of the beginning of the conversation about name data that I wanted to describe. So the concept is that at different points in the show, an audience who is kind of up and moving around with the people on stage have chances to contribute their creativity to the show through use of the phone on something that hopefully doesn't feel very much like an app. Something that they can whistle into and have it generate sound, something that they can move around and have it draw on these large screens, and so on. But their entry point into the experience is a name encoded in a QR code that describes a couple of things for us, right? So it's a link to a web app implemented on the Niantic 8th Wall WebAR platform. And that QR code bootstraps the relationship between each audience member and the show. We actually don't need to know much about them. When they log in, we identify that we create a name that identifies them uniquely, which I'll get to later. We specify a particular environment, so is it development, staging, or production, that we are running folks through, and we give them a group. So depending on which QR code they scan at which time, they kind of get assigned into a particular namespace that's used for the data that we're going to work with for this particular audience. And this is already exposed, more or less, or kind of part of just the way that we chose to work with this web platform. Each individual audience member has their namespace, which the group namespaces are assigned by Greek Muse from Arato through Kira. And this controls the types of things that they see on their phone. Again, I'm not going to go into too much detail on the show, though happy to do that, but more about the systems that are behind the scenes. But if we set aside the individual users for a second and just look at what we're controlling, in this web app, we're using A-frame, which is basically a document object model based way of manipulating a 3D landscape. We're not using it for 3D. We're using it just for DOM manipulation in 2D. But we have another namespace. We have a hierarchical document namespace that allows us to address things either by flat IDs or by where they fall in the hierarchy. And the way that we manipulate things for each individual user is based on what group are they in, what was that name that we assigned at the beginning, and what part of the document do we want to manipulate by name. Right, so we already have a couple names just in the very basic use of this platform. And this is from some software called QLab that we're using to not only trigger sound and video and other things in the show, but to control the phones. And what in fact we are doing is creating a kind of link between a namespace that describes who are we controlling. Default here means we're controlling all the groups. And the namespace in the document of individual entities that are named in that document object model that we're controlling on the phone. All right, so already kind of thinking about how to control the phone, we have a couple namespaces that we are connecting and working with here. I will explain kind of where this is coming from for a second. The first part of this namespace is something that I will describe later as being represented in Firebase. So we're using Google's real-time database in the kind of under the Firebase umbrella to move data around that's associated with these names. So a little bit of background as we kind of go through the examples. In that same web app, we are using a real-time sound processing tool called MaxMSP, which has been around forever, but now compiles to WebAssembly. So we write some sort of simple DSP code for things like blowing in the phone, doing kind of white noise detection for the breath and playing different sounds and so on. And in that tool, we also have to go from the internal names within that tool to URLs in a CDN on the 8th Wall platform. So we have, yet again, sort of name data. And the first example of mapping that name data to names that show up in a development environment. So you can see my sort of short names here for different audio buffers are mapped in some JSON file somewhere on the 8th Wall platform from an export that comes from this Rainbow tool into essentially relative URLs within the CDN. And that's how we get sounds out of this. Okay, so to start looking at the networking part of the concept for the show was to allow individual audience members, and to do this on the scale of about 50, but to think of the scale, what would scale up to, say, 1,000 audience members or something in like a Disney scale production. And so the idea is that we want individual users to draw on their phones without any kind of bootstrapping other than scanning a QR code and draw on these remote surfaces. This is a playtest of a specific example, so not the final design. Draw on these surfaces things that then go through a generative AI process to become elements of the show. So that's the objective. And in fact, the way that we get the data from the phones to the web application, or sorry, from the phones to the Unreal application where the data is represented, is through this name data hierarchy in Firebase. So at the top of the hierarchy, Healthy Dormouse, that's a unique name assigned for each audience phone, set in a cookie. The rest of the namespace is defined by the application, and we use a sort of pub/sub strategy to publish the position of the phone in AR space, right, in the AR tracked space, along with a few other things. Are they pressing, have they touched the phone? Which group are they in? And so on. And this name, we rendezvous with that named data through a URL, so another name, that connects us to a particular instance of Firebase, right? So on both the web app side and on the Unreal Engine side, where we're going to consume that data and draw something, we have to kind of merge the namespaces, or at least get a rendezvous link to the namespace. So we provide the database URL for the real-time database where our Firebase namespace exists. And then we have our other names show up in different places in the application. So for example, the generated names identify the audience members that I mentioned. So if we have a dashboard and we're looking for somebody and we don't want to know who they are because we want them to be anonymous, we can use these sort of simple names, again, these kind of application level simplified names to identify them. So this is kind of the ongoing catalog of names so far. So in the phone app in this project, if we ask sort of, well, what if this was done with NDN What we've sort of found is for this pub sub of simple data, position data, group information, controlling a DOM, kind of manipulating other things that we want to in this application, Firebase works really, really well. So if you want an example of like name data at an application layer that works for kind of quasi-performant web apps, Firebase is a good example. It's very close to what you would get from like pub sub of JSON objects in NDN. For this show, it uses HTTP uses HTTP streaming, I think, to get to the Firebase endpoint. And we have no firewall issues, no NAT traversal. We don't care what network people are on. The data just gets back and forth between our client and Firebase. And we have to do a round trip to the cloud that makes no sense. And gives us a little bit less sort of reliability in the case of disconnect if the show gets disconnected. But in return, we get no connectivity setup issues, no issues with what network people are on, which is a big deal for a large number of people. It's relatively fast, given that it's running on Google infrastructure, seems reasonably reliable, sort of. And pretty tolerant of like changing connectivity situations. You know, turning on or off Wi-Fi recovers pretty well. Seems to be a reasonably well-written library. All the security, of course, on that position data, group data, all the control messages that we're sending to turn things on and off on the phone are centrally secured, for better or worse, right? So definitely not decentralized. So, but all of this communication, so the what if the NDN part is local. We are paying for it, which I didn't think would matter, but it actually does. We have enough data moving through it that it's like a non-trivial amount of money for a small show to pay. It has to leave the building for stuff that is in between, like me and a screen that I'm looking at, which is stupid, right, is ridiculous. But it's sort of the cost of running these types of applications without something like NDN. There are some other sort of limitations here. It would really be nice to have integrated local storage, be nice to have local security authority. The whole thing requires an online service, which kind of we don't really need. It would be the pub sub part in particular would do very well with the kind of named data strategy. You publish it and try to get those interest packets to where the data has been, where the data is stored. Okay, very quickly, like why didn't we use NDN? It's hard to implement in a project like this that has many other moving parts. I am not totally up to speed on all the API research, but again, the sort of the distance between the typical NDN APIs and the Firebase style libraries is still a little fairly significant, and some of the other reasons that I mentioned up here, which I think people, if you're doing work with NDN, are aware of. Okay. So that's stuff on the phones. The phones are interacting with a virtual world, with the kind of eventual goal being that this is a persistent virtual world. So big screens looking into an Unreal Engine rendered virtual world. Lots of big screens. Come see the show, especially if you like roller disco. And so we're using Unreal Engine 5.5. And as far as I can tell, I assume people know this is the game engine used for Fortnite, one of the kind of big 2 or 3 engines that are out there. And gradually it seems like they have moved in a direction, I think in kind of with the idea of persistent open worlds, the kind of metaverse vision of making the engine more and more suitable for essentially named data under the hood. And so if you turn on a remote control feature that we're using to manipulate the engine, you get actually something that says copy path show up in your context menu for different objects. This is a unique hierarchical path, unique hierarchical name for any given actor. And it turns out if you kind of, at least like what I can infer from using it, because we're sort of using it more than studying it, it is creating unique names, not just for stuff on disk, or stuff that's in the editor, but stuff that's created ephemerally for a given instance of the game. And they have a fairly sophisticated namespace behind the scenes that looks something like this. On the far left, though, these are the names that appear for the user in the outliner of the world. So if you create, let's say, a Greek shrine, and you call it BP underscore shrine, this is what's going to show up in your outliner. And somewhere there's an API call, right, to make a link between that thing that's showing up in the outliner and a unique path. And this path varies a little bit depending on the instance of the game. So we already have these unique hierarchical names. It'd be really interesting to sort of break down the namespace, but I'm not going to try to do that here. And so for remote control of the engine, we do a lot of kind of querying for what the names are that the designers know, mapping them to the things that we need to control in the engine, and then manipulating them essentially using REST calls. And the REST calls bring us back to having to know the IP address that we're talking to, and that would be one place where NDN could do something totally different and really nice here. So we're also doing other sort of munging of naming. This is a JSON, essentially JSON template for an RPC call that provides a certain kind of control of the game engine. You can already see there are a couple names. There's a path for the object we want to find, the function that we're going to call on that object, the request, and this gets bundled in, and the request, the get request, this gets bundled into a REST call, right? So we're, again, sort of working with user-specified system-level function calls and then data naming. On each of these rolling walls, there is also a tracker from a company called Moses. So these are what are used to track film cameras in virtual production. We have one on each wall. And they track some infrared reflective markers that are on the floor and provide fairly accurate position and rotation for these individual walls. So this is much more like kind of the historical IoT kind of way of working. So they have a kind of little, I think a little like Nook style box that publishes data over IP. You get 3 slots, so you can pick 3 IP addresses, no multicast, they might do broadcast, and you kind of distinguish between different processes by port number. But what you're really doing is you gave these walls a name, and they have a hierarchical data structure that describes things like location rotation, something that would be easily published as NDN. And we're kind of stuck with IP port addressing. There's no security. It's kind of classic sort of IoT or stage system. Similarly, come see the show. It has motion capture, kind of like, I don't know, campy motion capture, really low-tech motion capture. Doing sort of something similar, though, which is taking iPhone-based facial capture, some stereo cameras that are used to track bodies of individual performers, and it's publishing that same data using a very similar protocol, something called LiveLink from Unreal. That, again, is sort of naming the data, and then you kind of figure out how to move it around by IP addresses and port numbers. So we have a mix of like really interesting application level names on kind of the sensor side and the virtual world side that get tangled up in IP addressing. So asking some questions about what would this look like if it were NDN. The key one is the network representation would look a lot like the application data, right? We would be able to access those uniquely named things that represent skeletal meshes or data sources or textures, actors, all the things in that virtual world, they're already named. We just can't get to the names without going through an IP address, right? Without going through a REST call. So we could unify it and simplify things. That's kind of all of what the left-hand side is about. And similarly, on these lower level protocols, we have these benefits that I think folks are familiar with, right? Okay, last piece. So also in the show, we're doing some cloud service, some AWS-based generative AI. So you're seeing a mixture of mockups and things that are actually running. And the general idea is using this kind of phone drawing technique. People would, remember the one using Firebase, people will draw stuff in the show. Those drawings will go through generative AI process, sort of quasi-custom one, or actually custom one. It will be mixed with existing imagery from the show, so a photo of one of the muses, for example, one of the actors in the show, and be brought together into different media, different types of media that are used in the show. That's a mock-up. These are some things that are running. We're doing some 3D mesh generation, which is kind of fun. And these are just examples of kind of starting with sketches cut off, but starting with a sketch, getting an image, ending up at a 3D GLTF file that's been textured based on a reference image. So we go all the way from that sketch to the 3D image in a couple minutes on AWS. and then we bring those elements in to the show. And so in working with AWS, on the same show that already has Firebase and Unreal namespaces, we also have AWS namespaces. And so we start on our file systems with providing the uploads or organizing the uploads based on hierarchical names. You drop files that have a certain name structure, or Unreal writes files out that have a certain name structure. We have some Python code that reads them, kind of munges them around, gets them onto AWS and processes them. And those have at least 3 namespaces: the local file namespace, kind of abstract collection name that references the user, the group, remember the one set up at the very beginning, and then I think the trial run. And then we have a unique name that's constructed out of those, plus a prefix to make, or a suffix actually, to make it unique on the AWS side. And then if you have any familiarity with AWS, there are names everywhere, right? So there are names in the S3 buckets. There are names for the things stored in the S3 buckets. We use those to create sort of an organization that also defines environment, development, staging, or production, as well as the media. We send messages around using SQS and SNS services that also have names, right, within the AWS ARN namespace. We name processes, right, the lambdas that are running. We name the SageMaker endpoints. And eventually we pull things back into Firebase when we know stuff is for notifications out to the mobile and other places, so they get stuffed back in another hierarchical namespace, and in this case mapped to a local file system name that we need to load stuff locally. So many names in so many different places with so little relationship, right? So a lot of the relationship is some very basic things like the type of environment, development, staging, or production, the group or the user identifier, some other things that are kind of well known, and then everything else is sort of an amalgam of whatever the platforms have forced upon us. So in that sense, there's a lot of name design that could be done. I'm not going to talk about the other protocols that we're using. So under the hood, we have equipment that would run, digital audio protocols, lighting control, and so on. Some of them are name-based, and some of them are not so name-based. In each of these cases, right, we would like to really be able to deal with local, particularly the generative AI case, deal with local and network objects the same way, and kind of extend our envelope of security from, there being AWS's security somewhere and the way that it names things, and then our local systems being totally different and not integrated, certainly not in any security-related way. And we would like those to be unified. Right, a unified way of naming across local and network objects would save a lot of time, a lot of time. Why isn't NDN used in this case? We just can't kind of run. You can't compete with sort of the resilience and scale of AWS, though. It seems like it wouldn't be that hard to make something that is a little bit easier. So that's kind of one of the key takeaways for us. And at least at the time, and this is now my slightly dated perception, there wasn't a lot of impure interoperability. How could we make NDN more sort of viable in a varied sort of diverse environment using lots of different protocols? Okay, quick observations about opportunities to sum up across these 3 sort of name data regimes that we have within this particular application. Name data and functions are everywhere. They really were everywhere. I thought this would be much shorter, but when I started going through it, there was a lot of really fun places to find names. We would really like to see, or I could imagine using NDN. We've done shows with NDN before. The APIs just need to be a little closer, and things need to be sort of impurely integrated with the real world, in some cases, the way that we work. And the opportunity really seems to be in these kind of areas, sort of unifying the application level abstractions with the network, unifying approaches to accessing local and cloud data. Of course, there's some security benefits, and those actually we're seeing, that would be really useful here. We can't have stuff accidentally sending the wrong REST call or something like that. And so there's a lot of really nice benefits. And I hope it's been interesting for you to see a very quick tour of these kind of 3 aspects of this show and where the name data is, what the sort of opportunities are. If you want to come to the show, there will be tickets there, although I think they're not there yet. And we'll do a bit of behind the scenes on how these systems work.
I see a lot of opportunities, as you said yourself, and I keep seeing so many opportunities for NDN from all these applications. And I like that you put the slide, why isn't this done with NDN? And it seems like a lot of that, I'm not saying all, but maybe most of what you said comes down to a problem of quality of implementation. Is that the case, or is there more?
It's a good question. I mean, I think there's more. I think there's more, right? In the sense that it seems to be about, it would be helpful to have implementations that, I guess, to take Firebase as sort of an example, right? That you can kind of immediately get communication, storage. You actually get functions from Google Cloud, though we're not really using them, across many different languages, or across many different programming languages and many different environments that run essentially in about a minute. Like, you could set up a new Firebase environment in a minute. You could sit down and write some Python and JavaScript code in an hour, and it would run across any communication medium that you can get kind of HTTP moving. I'm exaggerating a little bit, but that you could get HTTP moving across, and with very little background knowledge on networking. And so it's also just sort of the ease of bootstrapping. You don't need to have your own DNS infrastructure. You don't. So some of it is kind of by owning provisioning in the cloud, Google can make the deployment of that kind of thing easy, and so that helps. And that to me is one of the main things. The other is sort of maybe the application level APIs, at least historically, have kind of remained fairly low level. And so I was trying to even look at some of the current APIs and think about, well, if I had a 100 megabyte object and I wanted to move it, like, will it work? So some of it is in that kind of quality of implementation. And then maybe a third area is part of one of the really interesting selling points for NDN is performance over disconnect, or kind of in cloud optional cases, right? Or under kind of intermittently connected conditions. And at least historically, the libraries have not been great at, when communication was changing underneath, to be sort of aggressive about reestablishing the NDN communication. And so the benefit, so when you can like go to Firebase, and as long as you have good connectivity, it works really well. And then, you can see that there's a problem about pulling the plug on some part of that infrastructure. There's not a clear way to demonstrate easily on NDN that you can pull the plug and have it work, right? Unless you really build it carefully. And so sometimes the high-level API goals also kind of don't allow you to demonstrate some of those really interesting underlying behaviors.
Thank you, Jeff.
Thanks.